In 4.1 and 4.2, we will talk about inverse trigonometric functions. Now recall that for a function to have an inverse, it must be a one-to-one function. So you may recall this from college algebra. A one-to-one function must pass the horizontal and vertical line tests, which means if you draw any horizontal or vertical line, it can only hit the graph once. So let's take a look at the function of sine of x. If I draw a horizontal line, guess what? It's going to hit the graph multiple times. So this is not a one-to-one function. But for this to be a one-to-one function, one thing we can do is we can restrict its domain. So notice that if we only take the portion from here to here, if we only take this portion, so imagine the rest of the graph doesn't exist, and then we draw a horizontal line, it only hits a graph once over here. If I keep going though, it's going to hit it twice. So that's why it's imperative that I only utilize this section of the graph for my domain. So this here is negative pi over 2, and this here is pi over 2. So between negative pi over 2 and pi over 2, so within this domain, my function is going to be one-to-one, which means that it can have an inverse. So once again, I'm looking at just this portion of the graph right here, negative pi over 2 to pi over 2. Just in that little portion, if I draw any horizontal line, it's only going to hit the graph once. Therefore, this portion of the graph of sine of x will have an inverse. Another thing to remember is that the domain of a function becomes the range of its inverse and vice versa. Okay, so the domain of this is negative pi over 2 pi over 2. That's going to be a restricted domain, so this can be a one-to-one function. And the range is negative 1 to 1. So this is negative 1, this is positive 1. For an inverse, the domain and range are going to flip-flop. The domain becomes the range, and the range becomes the domain. So the inverse of sine of x, written as y equals to sine with that negative 1 as the superscript, or y equals arc sine of x, they both mean the inverse. Okay, so if you have y equals to inverse sine of x or arc sine x, then these both represent the inverse of sine of x. So because the domain and range, they flip-flop, the range of in the inverse sine of x is negative pi over 2 pi over 2, and the domain is negative 1, 1. Now similarly, for the graph of y equals cosine, we're going to restrict on the interval 0 to pi in order to have a one-to-one function. So the domain of the inverse cos x is negative 1 to 1, and the range is 0 to pi. Same thing for tan. Tan is going to be restricted on the domain negative pi over 2 comma pi over 2. So the inverse will have the domain of negative pi over 2 pi over 2. And the inverse is once again written as inverse tan x or arc tan x. Now I'm going to simplify this for you guys in the examples. Okay, so the inverse sine of x, our range is between negative pi over 2 and pi over 2. So if we were to look at this from the perspective of a coordinate plane, this is 0, this is pi over 2, this is pi, this is 3 pi over 2. Now remember, 3 pi over 2 is same thing as negative pi over 2, because if you go in the clockwise direction, that's what we do to get a negative angle. That'll be negative pi over 2. So for sine of x, we're going to be restricted in these two quadrants, which are quadrants 1 and 4. Now cos x, our range is restricted between 0 and pi. So if this is 0, this is pi, then for inverse cos x, we're going to be restricted on quadrants 1 and 2. And then tangent of x is restricted between negative pi over 2 and pi over 2. So same thing as sine. We're going to be restricted in quadrants 1 and 4, because this is pi over 2 and this is negative pi over 2. So we're going to keep this in mind when we find our inverse functions. A quick refresher, we've seen this before. We have a 45, 45, 90 triangle, so the ratios are going to be 1, 1, radical 2. So opposite of 45 degrees is 1, opposite of 45 degrees is 1, and then opposite 90 degrees is radical 2. And then for 30, 60, 90, it's 1, radical 3, 2. Here are some quick important reminders that radical 2 over 2 needs to be rewritten as 1 over radical 2, and radical 3 over 3 needs to be rewritten as 1 over radical 3. So please keep those in mind as we do this. Okay, let's evaluate the following expression. Your angle must be in radians and in the interval negative pi over 2, pi over 2, since we have an inverse sine of radical 3 over 2. So first off, our inverse sine is only going to be restricted to quadrants 1 and 4. Now remember, this is all students take calculus. So in quadrant 1, sine is positive, and in quadrant 4, sine is negative. So in this case, because we have inverse sine of radical 3 over 2, we are going to draw this triangle in quadrant 1 because that's where inverse sine is positive. And because we have inverse sine, we're only going to be restricted to quadrants 1 and 4. Okay, so let me draw my triangle. It's going to be my reference triangle here. So we want to figure out for which angle x is the sine equal to radical 3 over 2. So sine is opposite over hypotenuse. So for angle x, my opposite is radical 3, and my hypotenuse is 2. So then I ask myself, well, what is x going to be? Opposite of radical 3 is going to be 60 degrees. So for which angle x is sine of x equal to radical 3 over 2? Well, so the way I'm going to write this is that inverse sine of radical 3 over 2 is going to be 60 degrees, which, if I convert this into radian form, is going to be pi over 3 radians. Now, notice that this is a little bit different than solving an equation. It's a little bit different than solving an equation, because if I'm solving an equation, sine of x equals to radical 3 over 2, that's different. I'm asking myself for which angles x is radical 3 over 2, and we can include all the angles of x that are whose sine is radical 3 over 2. But when we just have inverse sine of radical 3 over 2 without, so this is without an equation, then we got to go back to this rule here, that the inverse of any function has to be restricted so that the original function is 1 to 1, which is why we can only restrict ourselves between negative pi over 2 and pi over 2. So if we have an equation like this, then x could equal to pi over 3 and then plus 2k pi. So, you know, any angle that's coterminal with pi over 3 will work. Okay, that's if we have an equation, but in this case we don't. We just have an inverse sine of radical 3 over 2, and so for an inverse we can only be restricted to quadrants 1 and 4 for inverse sine, which is going to be between negative pi over 2 and pi over 2. Let's take a look at another example. So in this case we have inverse sine of negative radical 3 over 2. Once again, anytime you have inverse sine that's not part of an equation, we're going to be restricted to quadrants 1 or 4. Now here, sine is positive, and then in quadrant 4, cosine is positive, so sine is negative. So because we have now inverse sine of negative radical 3 over 2, we're going to draw a reference triangle in this quadrant, quadrant 4. Now sine is opposite, which is negative radical 3, over hypotenuse, which is 2. And then opposite of negative radical 3 is going to be 60 degrees. Now here's where we have to be careful. Normally we measure our angle in standard position, so normally we would do this. We would say, what is this angle? However, when it comes to inverse sine, we are not going to do that because angle has to be between negative pi over 2 and pi over 2. It has to be in this interval. All right. So because it has to be in that interval, we're actually going to measure the negative value of this angle. So this angle here, we're not going to measure in standard position. Instead, we're going to measure this just going down clockwise. So going down clockwise, this angle will be negative 60 degrees. Okay, so this angle x is going to be negative 60 degrees. We have to measure it going clockwise because our angles can only be between negative pi over 2, which is negative 90 degrees, and pi over 2, which is positive 90. Okay, and then if you measure it clockwise, this would be like 240. 240 will not be, 300. 300 degrees, which is going to be this angle in standard position. It's not between negative 90 and 90. So we have to measure this angle going clockwise, which means we have to measure it using a negative degree. So this is going to be negative 60 degrees, which if you convert that to radians is going to be negative pi over 3. Now you may have questions, so please save them for class. Okay, let's take the arc secant of negative 2. So first off, arc secant, I'm going to rewrite this as inverse secant of negative 2. Arc secant, inverse secant are the same thing. And then I'm going to rewrite this in terms of cosine. So remember that secant is a reciprocal of cosine. So this is going to be inverse cosine of negative 1/2. Now remember, cosine can only be in quadrants 1 or 2. It can only be in these two quadrants. So here everything is positive. In quadrant 2, sine is positive. So as far as cosine goes, cosine is positive in quadrant 1, and cosine is going to be negative in quadrant 2. Okay, because now we're looking at cosine. So it's positive in 1, negative in 2. Because this is negative 1/2, I'm going to draw my reference triangle in quadrant number 2. If it was positive, it would be in 1, but it's negative, so it's going to be in quadrant 2. All right, now let me put in my ratios. This is angle x. Cosine's adjacent over hypotenuse, so my adjacent is negative 1, and my hypotenuse is 2. So I'm going to have negative 1 and 2. Now be careful, because if it's a 1 radical 2, if the hypotenuse is radical 2, then it's a 45, 45, 90. But when it's a 1 radical 3, 2, in other words, when the hypotenuse is 2, then it's going to be a 30, 60, 90. So if this is negative 1, this is going to be radical 3. So I want to ask myself, what is that angle right there? That reference angle. So that reference angle x, this is going to be 60 degrees. Now in this case, I do want to measure the angle in standard position because pi could be between, or inverse cosine could be between 0 and pi. So this angle here in standard position is going to be, I know the whole thing is 180. So if I take 180 minus 60, that's going to be 120 degrees. So if I take 120 degrees and I convert this into radians, it's going to be 2 pi over 3. And the reason I can measure it in standard position, once again, because inverse cosine could be between 0 and 180. And 120 is between 0 and 180, so we can do that. Okay, let's take the inverse cosine of negative 1. So as soon as we have inverse cosine, we know that we're going to be either in quadrant 1 or quadrant 2. Whenever we have sine or cosine having a value of 0, 1, or negative 1, that means it's going to be a quadrantal angle for 0, 1, negative 1. So this point here is 1, 0. This point here is 0, 1. And this point here is negative 1, 0. Cosine is associated with the x value. So we're going to ask ourselves, for which angle is the x value on the unit circle equal to negative 1? That's going to be this angle right there, which is pi. And cosine has to be between 0 and pi, so pi is going to be a valid answer. Next example, we got arctan radical 3 over 3. First thing I'm going to do is I'm going to write this as inverse tan. And you can use the arctan notation if you want to, but I'm going to write that as inverse tan. And radical 3 over 3 needs to be written as 1 over radical 3. So remember that tangent has to be on the interval negative pi over 2, pi over 2. This is negative pi over 2. This is pi over 2. So tangent can only be in these two quadrants. Now in quadrant 1, everything is positive. In quadrant 2, cosine's positive. So as far as tangent goes, it's positive in quadrant 1, but it's negative in quadrant 4. So what I'm going to do is I am going to plot angle x, and because tangent's positive, I'm going to plot it in quadrant number 1. This will be my angle x, and tangent is opposite over adjacent, so this will be 1 over radical 3, opposite over adjacent, and my hypotenuse is 2. I ask myself which angle in 1 radical 3, 2 is opposite of x, and that'll be 30 degrees. Now 30 degrees, if I convert that into radians, this is going to be pi over 6. Now remember, this can only be between negative 90 and 90. So 30 degrees is between negative 90 and 90, so pi over 6 is a valid answer. Let's do one last one. We got arctan negative radical 3 over 3. Once again, I'm going to rewrite that as the inverse tangent of negative 1 over radical 3. Remember, I told you guys that anytime you got radical 3 over 3, you got to replace that with 1 over radical 3. So now tangent can only be in quadrants 1 or 4, but in 1 it's positive, so it has to be in quadrant 4. So I'm going to sketch my reference triangle. Okay, so tangent's opposite, so opposite is going to be negative 1, and the adjacent is going to be radical 3, which means the hypotenuse is going to be 2. We ask ourselves which angle is opposite of negative 1, and that'll be 30 degrees. But once again, remember, I cannot measure my angle in standard position, because in standard position this would be like 330, and our angles can only be between negative 90 and 90. So for sine and tangent, we're going to measure our angles in negative degrees. So if this angle is 30 degrees, if I measure this going down clockwise, this will be negative 30 degrees. And if I multiply that by pi over 180, this will be negative pi over 6. All right, the rest of these we will do in class.